Hey guys, it's Erica from Bradbury's Chemistry 112 class, and today we're going to be talking about the valence bond theory, and FCCF is our example. To start things off, I'm going to do the Lewis dot structure because that helps me do the VSEPR diagram. So, looking at the periodic table, I know that fluorine has 7 electrons. There's 2 of them, so that makes 14. Carbon has 4 valence electrons. There's 2 of them, so there's 8. Altogether is 22 electrons. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and 22 electrons. Now this tells me, since we are treating carbon as the central atom, there are no lone pairs to affect the bond angles here. So there's nothing to push them down, which means it's just going to be linear, just straight across. So we're going to show that page here. So it's a linear shape. Looking at carbon, there's only 2 electron groups. So there's one here and one here. Even though there are 3 bonds here, it's still considered just one electron group. And so the bond angle is 180 degrees because it's all in the same plane here. From the carbon, there's nothing coming out at you, there's nothing at the bottom here. It's just all straight across 180 degrees. And because it's a linear shape, that tells me it's going to be a sp hybridization. You would think it would be something different because there's 4 bonds. That's because there's going to be 2 sp and there's going to be 2p. And we'll show you that in just a second here. So because we have a double bond, or really it's a triple bond, we're going to have the sp here, which is going to be a sigma. And then we're going to have the other sp over here. This is the other sigma bond. These are the fluorine here. And then these are going to be the 2p, which makes these the pi bond. So now we're going to do the box diagram. So I just split it in 2 so we can see all 4 atoms together. I'm going to draw the fluorine over here. So first thing we need to do is we're going to, we need this electron to be up here, so that means we need to add energy. I apologize for my handwriting. I would blame it on the tablet, but I have bad handwriting to begin with. Because this is energized, we're going to make it a little star. 2s and 2p. So this one is going to get a promotion and it's going to come up here. So it leaves us with just 1 and the 2s. And we have 3 and the 2p. So we promote. Same thing with the other carbon. gets promoted. Okay, so next we're going to do the hybridization. I'm just going to have the fluorines up here. Now, because we already know that there's 7 valence electrons, I'm just going to write the 2p because we already know that the 2s is filled. So I'm just going to go straight to 2p. So there's only 1 here to make a bond. Same thing with the other fluorine. And then next is to hybridize. We're going to do these 2 here, which leaves the 2p's. So we have SP, and then we just have 2p. Because the 2p was not hybridized, it's going to actually have a little bit higher energy level than the SP. So we have 2, 3, and 4. Same thing with the other carbon. Hybridize. The SP. And then the 2p. And 4. So the fluorine is going to bond with this SP. Same thing with the other fluorine. And then the carbon, this is going to be this sigma bond between the SP for carbon and then the other 2p's. So now all 4 are bonded. And then last we're going to do the contour diagram. So this is my little guideline here. We have 1 carbon and the other carbon. Here's our first SP with the 2 electrons. And then the other SP with the overlap. Same thing over here. And we're going to have fluorine over here. Fluorine was not hybridized, so it's going to stay that P shape. It's not going to have the hybridized shape as carbon. So here's my little figure 8 for P. Same thing over here. So here's our overlap. That's our carbon-fluorine bond here. So that makes it a sigma bond. Next we're going to do our 2p bonds because they are P. P is that figure 8 shape. The way to draw that is they kind of look like bunny ears. So we have, this is one of the P's. And this is the other one. And each of these is only going to have 1 electron in them. because as we saw before in the box diagram, each of the 2p's only had one electron in each spot. Same thing with the other. One bunny ear, two bunny ears, and there's the last one, and then two electrons. This is going to bond here. The last one's going to come way over here. Sorry, I didn't mention before, that was the other sigma, and then these are the pi bonds. Sorry. And I forgot to mention that, oops, I'm sorry, that this is all 180 degrees. Thank you guys so much for listening and for your patience. I know my handwriting was a little all over the place, but thank you guys. Take care.